Core 3, June 2007, question 7. Lots of differentiation to do here. And we're starting off using the product rule, aren't we? So we'll let u equal x squared take away 3. Differentiate that, gives us 2x. And we'll let v equal e to the x, which differentiates nicely to e to the x. The rule for dy by dx here is v du dx, those two things times together, 2x e to the x, plus these two things times together, x squared minus 3 e to the x. And that's the right answer, but we're going to have to differentiate this thing again in a second. So a nice thing to do here would be to multiply it out. I know we don't often do this. And you see here we've got a factor of e to the x in the whole thing. And so we could tidy it out all to give that. Let's go again then. We've got to differentiate this thing again now, and that is why doing that was so useful. So we can now let u equal the first bit here, and let v equal the e to the x again. Du by dx is 2x plus 2, and dv by dx is simply e to the x. Chain rule again, dy by dx, no, d2y by dx squared this time, sorry, is e to the x times by 2x add 2 plus e to the x times by the x squared thing we started with. Again, if you did want to tidy that up, you could work it all out to be that, but this is good enough here for the 2 marks there. So we got 2 marks for the blue one, 2 marks for the red one. What have we got to do now? Find the x coordinate, the stationary points. Now we've done 2 things here, got to be careful which one we want. And why not write it? At stationary point, what do you want? We want dy by dx to equal 0. So that's this one, the blue one here. We want x squared plus 2x minus 3 times by e to the x equals 0. Simple factorizing here. And then we've got 3 things here. What can equal 0? Well, that equals 0 when x equals minus 3. There's one answer. That equals 0 when x equals 1. There's another answer. And e to x never equals 0. So we haven't got any answers there. Is that all we wanted? Find the x coordinates. Yes, that's all we were asked to do. And finally then, determine the nature of each of the stationary points. So to find the nature, we want to drop them into the d2y equation. d2y by dx squared, we're putting in a minus 3 in here, sticking a minus 3 into all of this. We've got e to the minus 3, that's still positive, isn't it? Minus 3, then we've got 9, take away 12, take away 1. And that's going to be negative, isn't it? So it's negative, therefore it's a maximum. And just repeat the same idea with the throwing in the 1 as well, and that turns out to be positive, so it's the minimum.